Hello student, I hope everything is doing well. This will be the video lecture for our online week. I want to begin by reviewing with you the reading that I required you to do last week, in addition to having a test last week. The application of derivative. I had you read some chapter 3.1 and 3.2, and what the chapter is about is the application of derivative. Okay, what is the application of derivative? Well, in a function, when you're given a function, you'll be able to graph it. But you'll be able to graph only the common function that we have explored so far, like linear function, quadratic function, polynomial of like exponential to the third, to the fourth, and stuff like that. So this is an example of a polynomial function. And so the material that you read last week talk about some terminologies. For example, maximum, minimum. They call it extrema. So in a function, when you graph it, you'll be able to see the behavior. And you will also be able to see some, spike up and spike down. Well, in everyday language. But the spike up and spike down, it the maximum minimum points for the function. This is what we call a local maximum, local minimum, and then some local maximum. And so we also have a term called absolute maximum and absolute minimum. It has something to do with when we're looking at a function, not in the entire domain from negative infinity to positive infinity, but within a certain defined domain. Okay, so let's look at this example right here. In a certain defined domain between s sub 1 to s sub 3, you can see that we have absolute maximum and absolute minimum defined. Maximum and minimum can be defined on the endpoint or somewhere between the interval of s sub 1 and s sub 3. And so how do we find those values? That is where the application of derivative is. Okay, so and then you also look at the terminology called critical number. So what is critical number? Critical number is when you look at a function, you take the derivative of that function, and you determine that it's critical numbers when you have an s value that is either have a slope at 0. Okay, taking the derivative means knowing the slope of that particular function at a certain point. Okay, so when you have a slope of 0, or when you have the area, the point where it's undefined. Okay, so let's talk about the slope of 0. Do you know what it means for a slope to be 0? Okay, let's go back to this function right here. You can see that this is the function when we are able to graph it. But in the event that we can't graph it and we use the application of derivative, okay, we use the application of derivative by taking the derivative and then set it equal to 0. We saying that the slope right here of that function is 0. And here is another point where the slope is 0 when you take the derivative, okay? And then any other point when you take the derivative, let's say for this one right here, okay, you can see that the slope is not 0, the slope is some positive value. And then let's say you have some point, let's right here, okay, you can see that the slope has some negative value, but not 0. So you can see we can determine the maximum or the minimum by knowing where in the function we have a slope of 0. And that is when we have to take the derivative of the function and set that derivative to be 0. Because remember what I said? Taking the derivative means finding the slope of a certain value at a certain s value. Okay, so that is what we call critical numbers, and I hope that you keep that in mind as I do some example. Okay, so that would be just a some example, some review about the application of antiderivative. When I come back to the next video, you will be looking at example problem number 1. Okay.